Let's talk about certification review number 11. First off, find the absolute minimum and maximum of f of x is equal to sine x over 2 minus cosine x on the interval from 0 to 2 pi. Okay, so first let's figure out the possible critical points. F prime of x is equal to derivative of the top times the bottom minus the top times the derivative of the bottom, and the derivative of the bottom will be plus sine x over the bottom squared. So that'll be equal to 2 cosine of x. Then I have minus cosine squared minus sine squared for minus 1 over 2 minus cosine of x quantity squared equals 0. Okay, so that means that cosine of x has to be equal to 1/2. And in the interval from 0 to pi, so we're only looking at the interval from 0 to pi, the only place where cosine of x is equal to 1/2 is if x is equal to pi over 3. Okay, so that's the one critical point, x equals pi over 3. So to figure out the absolute maximum and of this function, we have to check 3 points. We have to check out pi over 3. We also have to check out f of 0. And we also have to check out f of pi. Okay, we need to check the endpoints, and we also need to check the critical point. F of 0, sine of 0 is 0. F of pi, sine of pi is pi, so those are easy. Pi over 3, sine of pi over 3 is square root of 3 over 2, divided by 2 minus the cosine of pi over 3, which is 1/2. So we end up with square root of 3 over 2 divided by 3/2, which makes square root of 3 over 3. So the absolute maximum is square root of 3 over 3, and the absolute minimum is 0. So it's important to check both the critical points and also the endpoints to find the absolute minimum and maximum of a continuous function on a closed interval. Problem number 4 is a related rates problem. So we have a situation, we have a street corner. Okay, so Kevin starts here, Brittany starts here, and then Brittany comes to the west. So let me mark that in red. So Brittany is going this way at 8 feet per second. Meanwhile, Kevin runs north and is going this way at the rate of 3 feet per second. How fast is the angle theta changing between them when Kevin has gone 60 feet? Okay, so let's take, here's our angle here, theta. So here's the distance b, and here's the distance k. So we need to figure out a relationship between theta, k, and b, and for this particular problem, it's clearly tangent of theta is equal to opposite over adjacent. So taking the derivative, we get that secant squared of theta times d theta dt is equal to derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Okay, now let's figure out the values to plug in. dk dt is given to be equal to 3. Also, dB dt is given to be equal to negative 8. Negative 8 because the distance b is decreasing as time goes by. Now, when Kevin walks 60 feet, we know that, so we know distance for Kevin is 60. So we know that the time elapsed is 20 seconds. Therefore, the distance b is going to be equal to 240 minus 8 times 20. So 240 minus 160 makes 80. Okay, so at the time in question, k will be equal to 60, and b will be equal to 80 at the time in question. Okay, so that means on the right-hand side, dk dt is 3. B is given to be equal to 80, or not given, but we figured out that B is 80, minus K, which is 60, times dB dt, which is negative 8, divided by B squared, which is 6,400. And on the left-hand side, secant squared of theta. So secant is 1 over cosine. The cosine here, if this side's 60 and that's 80, then the hypotenuse is 100. So the cosine of theta would be 8 over 10, 4 over 5. So secant squared would be 25 over 16. Okay, so d theta dt is equal to 240 plus 480 divided by 640 over 25/16. So then we simply have a simple equation here to solve for d theta dt. So I won't do the numerics for the sake of time. The answer will be some number in radians per second. Radians per second, not degrees per second, because in calculus everything is measured in radians.